And this is the review for section 4.3. Find all real numbers that satisfy the equation. This time we have secant, cosecant, and cotangent type of equations. But we do very much the same thing. We first solve for the function. This gives us secant 2x equals 2 over square root of 3. Now don't bother rationalizing yet, because secant, we can change that to cosine. And then that will switch square root of 3 over 2. Cosine's 1 over secant. So if secant's 2 over something, cosine will be that something over 2. Now we can take arc cosine. The reason why I wanted to switch is your calculator doesn't have an arc cosecant, or sorry, an arc secant, or an arc cotangent. None of those. So we're going to go back to our regular functions so that we can utilize our calculator more easily. 2x equals arc cosine of square root 3 over 2. Divide by 2. Let's put a 1/2 in front. And we have our solution. X equals 1/2 arc cosine square root 3 over 2. Now there's no rounding, no decimal, anything like that on this problem, so this is a unit circle value. Where is cosine square root 3 over 2? The answer is 30 degrees, or pi sixths. So this is 1/2 of pi sixths, which is pi twelfths. However, that's not the only answer. First off, it says find all solutions, so we know we're going to have to do some kind of k pi, 2k pi business. But also, keep in mind we were trying to solve where is cosine equal to square root of 3 over 2. Now it was 2x and all, but where does cosine equal a positive number? It turns out that cosine's positive pi twelfths here, but also here, which would be 23 pi twelfths. That's just 2 pi minus pi twelfths, because this is exactly 2 pi minus pi twelfths. So we have pi twelfths, we have 23 pi twelfths. And to get all, again, we're looking all real numbers, we need all of these forevermore. That's pi twelfths plus 2k pi, and we need 23 pi twelfths plus 2k pi. Those are going to be our solutions. Let's write them down. So x equals pi twelfths plus 2k pi and 23 pi twelfths plus 2k pi. And you might also write where k is an integer. The book might also have set notation around this. The set notation would look like this. Move it over a little bit. Set of all x's such that, like that. So just depending on how you need your solution, there's a couple ways to write it. And we've completed this problem. Let's move on to the next one. Okay, cotangent. I don't know cotangent on my calculator as easily as I know tangent, so I'm going to change to tangent. When I change tangent, cotangent, it reciprocal, 1 over 1. That's the same thing, it's still 1. Okay, where is tangent 1? Pi fourths and 5 pi fourths. Now I went to pi fourths because I know tangent is 1 at pi fourths. I went to 5 pi fourths because of our knowledge of all students take. Tangent's positive in quadrant 3 as well. So a pi fourths angle in quadrant 3, that is pi plus pi fourths. Pi is 4 pi fourths plus pi fourths is 5 pi fourths. And again, they want all real numbers. So Let's do the set notation. Set of all x's such that x equals pi fourths. Now let's see, how can we do this? There's two ways to do this in this case. We can do pi fourths plus 2k pi and get all those. And we can do 5 pi fourths plus 2k pi and do all those. However, since these are equal distance in both directions, we can just do pi fourths plus pi k pi. Pi fourths plus pi plus pi plus pi plus pi over and over and over, and continue to just get these two solutions and nothing else. That's more efficient than the other method, so this would be plus k pi. That adds 180, half a circle. That's it. Next question. All right, this is back to a little bit easier one. It's already cosine instead of secant. This time they only want the answers one time around the circle. And notice the parenthesis, 360 would not be an answer. 0 would be the appropriate answer if it's the same. So next thing we need to look at is, where is cosine negative? Square root of 3 over 2. Cosine is negative in the quadrant 2 and quadrant 3, because all students take calculus, cosine's positive in quadrant 1 and 4. Now where is cosine square root of 3 over 2? That's 30 degrees. So this value is 30 degrees. Let me write it down. Cosine of degrees, 30 degrees, equals square root of 3 over 2. So 30 degrees is our reference angle. So this one is 180 minus 30. This one's 150 degrees. And this one's 180 plus 30. This one's 210 degrees. We don't need any plus k pi business here, because they only ask for the values one time around the circle, which is exactly what we have. Theta, it's not x, this time it's theta, equals 150 degrees, comma 210 degrees. And that's it. Next question. This one's also between 0 and 360. We first have to solve for the sine. This gives us, let's see, 2 sine 2 theta equals square root of 3. And divide by 2. Sine 2 theta equals square root of 3 over 2. Now, commonly the books will solve for theta by doing arcsine and then divided by 2, and then writing all the answers, so the plus 2k pi business, or in this case degrees, plus 360k, and then figure out which ones work between 0 and 360. I have a better way. In my opinion, it's better. I've found that it's a lot faster. So first off, this 2 tells me that I'm going to need to go 2 times around the circle, finding where sine equals square root of 3 over 2. That would be at 60 degrees, and let's see, 180 minus 60, 120 degrees. That's 1 time around the circle. We also have all the way around. That would be 360 plus 60, which is 420 degrees. And then 480 degrees. Where these values come from, 60 and 120 is easy, but 180 minus 60 gives you the 120. 360 plus 60 gives you the 420. 360 plus 180 minus 60 gives you the 480. So why does all this work? Well, 60, that's easy. 180 minus 60 gives you the 120. 360 plus 60 gives you the 420. and 360 plus 180, which I didn't think what the final answer that is, but 360 plus 180 minus 60 gives you the 480. These are the four values going twice around the circle where sine is a positive square root of 3 over 2. Notice this is only quadrant 1 and quadrant 2, but that's where sine is positive. So this gives us, therefore, this fact that 2 theta equals 60 degrees, comma 120 degrees, comma 420 degrees, comma 480 degrees. But we still have to divide by 2 to solve for theta. So theta equals 30 degrees, 60 degrees, 210 degrees, and 240 degrees. All four of these answers are within 0 to 360 degrees. Now previously, these answers, all of these answers, were outside of one time around the circle, but we still hadn't solved for theta. We had 2 theta. So when we divide by 2, all of a sudden it scales all of these to the appropriate domain, 0 to 360. I found that this is the most efficient way to solve these. So when you finally get solving for the trig function and it's a multiple angle like 2 theta, 3 theta, 1/2 theta, whatever it is, that number tells you how many times around the circle to get your answers. Now this is only for the problems like this one where they specify one time around the circle. If they say find all solutions, we're going to be doing in this case 60 plus 2k pi, or sorry, 60 plus 360k, and 120 plus 360k, and that'll be that. But if they specify like one time around the circle, then, and we end up with 2 theta, then we get all the answers twice around the circle, knowing that one of our last steps will be divide by 2, which will scale them back to where we want to end up. Hopefully there's a couple more of these in this homework, in this review set, so I can continue to talk about this. Next question. This problem, we're in radians, and it's a multiple angle, 4x. So one time around the circle, and we have 4x, our last step would be divide by 4. So we're going to end up going 4 times around the circle to end up with all of our answers being one time around the circle. Let's take a look. First off, now we already did this as far as where is sine, square root of 3 over 2. And we know one answer in radians is pi thirds, and the other one's in the second quadrant. This is 2 pi thirds. But that's only one time around the circle. So if we wanted to add in pi thirds, and this is kind of a nice way to do it, pi thirds, 2 pi thirds, 3 pi thirds, 4, 5, 6, 7 pi thirds. We're now in the second time around the circle. 8 pi thirds, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Last time around the circle, 19, 20, 21, 22, 23, 24. 24 pi thirds would be 8 pi. That is 4 times around the circle. Perfect. Now this was a nice way to do this in terms of pi thirds. These are how you add the pi thirds. 1, 2, 3, 4, 5, 6. And then 6 pi thirds is 2 pi. We're back to starting over. 7, 8, 9, 10, 11, 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 2, 3, 4. So we ended up with 8 answers in this process. So we have 4x equals pi thirds, 2 pi thirds, 7 pi thirds, 8 pi thirds, 13 pi thirds, 14 pi thirds, 19 pi thirds, and 20 pi thirds. And our last step to solve for x is divide by 4, etc., dot, 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 dot. We will have x equals pi twelfths, pi sixths, 7 pi twelfths, 8 pi, let's see, 2 pi thirds, 13 pi twelfths, 14, 7 pi sixths, 19 pi twelfths, and 5 pi thirds. And 5 pi thirds is 1 pi third short of 6 pi thirds, which is 2 pi. So all of these are within one time around the circle. Now, as an example for how I was computing some of these, I was all doing them in my head, but if you were to take like this one, 2 pi thirds times 1/4, reduce, reduce, that is pi over 6. Or, let's see, this one, that's 20 pi thirds times 1/4, 5 pi thirds. So some of them reduce. Other ones, like the first one, that's pi thirds times 1/4, that's just pi twelfths. So dividing by 4 is nice when you don't have fractions, but when you do have fractions, multiplying by 1/4 makes it a lot easier. So we ended up with 8 solutions to this problem. When you have a problem that says solve and they want you one time around the circle, but it's a 4x, you need to go 4 times around the circle to get all the answers, so that when you divide by 4, all of the answers one time around the circle will be your final answer. Our last problem said sine 2x. We went twice around the circle. If this says sine 1/2 x, you only have to go half around the circle to get looking for solutions. All right, let's take a look at another example. Now this one is still between 0 and 2 pi. So we're in radians and one time around the circle. Let's solve for the basic function first. So we have 2 cosine x equals -1 and cosine x equals -1/2. Alright, where's cosine -1/2? That's 60 degrees. This one and this one. Because cosine's positive in quadrant 1 and 4. All students take calculus. But it's negative in quadrant 2 and 3. And we know that cosine of pi thirds is 1/2. So our reference angle is pi thirds. So this value would be, well, let's just count in pi thirds since we've already done this. 1 pi third, 2 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 4 pi thirds. Now how many times do you need to go around the circle? Just once. Because this is just cosine 1x. So we're done. We don't have to go twice around the circle or any more, because it's x equals 2 pi thirds, comma 4 pi thirds. Okay, next question. Alright, this problem, we're looking for degrees and we're looking for all angles. So this is going to be plus 360k or that kind of answer. In degree mode. Nearest tenth. So we're calculating this. Calculators. And because it's all angles, we don't have to worry about 3 times around the circle or anything. We're getting all of them. So what we're going to start with is ask ourselves, when is sine equal to 0.593? So if we do arc sine, we get the angle, I'll call this 3 alpha right now, is, oh, that didn't work, there we go, 593. We go to our calculator for that part, squeak, And we get arcsine. Make sure you're in degree mode. 593. 36.37 degrees. So we're going to go with 36.4 degrees because of our to the nearest tenth. We have to continue on with this though because arcsine, the 36 degrees right here, where is sine 0.593? There's two spots. There's also one over here, and that's 180 minus 36.4, which is 143.6. So if I were to express our solutions in terms of 3 alpha, we would have these two answers for all real number solutions. We'd have 3 alpha equals 36.4 degrees plus 360 degrees K, and also 143.6 degrees plus 360 degrees K. So these are all these answers forever and ever and ever, and all these answers forever and ever and ever and ever. Now, very much like our previous problems where we write down all the solutions equaling, like in this case 3 alpha, and then divide by 3, you want to write all of the solutions for the 3 alpha, all of them, then divide by 3. And this divide by 3 goes everywhere, giving us our final answer of alpha equals, now 36.4 divided by 3. 6.4 divided by 3 is 12.1, rounded to the nearest decimal, 12.1 degree. 360 divided by 3 is 120 degree. That also gets divided by 3. 143.6 divided by 3 is 47.9, rounded to the nearest decimal, 47.9 degrees, and that's also plus 120 degrees K. So again, when you have multiple angles, like 3 alpha, write down all the answers that you need before you divide by that 3 to get your final answer. Let's move on to the last problem. Alright, find all real numbers. So we're going to have that plus 2k pi kind of thing. Round approximate nearest hundredth. So we're going to be using our calculator. It does not specify degree or radian. Usually when that's the case we go with radians. So let's go with radians. Make sure your calculator is in radian mode. We have to start off by solving for our trig function. In this case we have 10 cosine of x halves equals 3, and then divide by 10. And we have cosine of x halves equals 3/10. Now had this problem instead of been all real numbers, had been between 0 and 2 pi, we would then start looking only 1/2 time around the circle where cosine equals 3/10. But since it says all real numbers, we're going to look for every place around the circle. Alright, so let's go to our calculator and do arc cosine of 3/10. Now although it says round to the nearest hundredth, since I'm not done with this problem, I still have another step, specifically this times by 2. I don't want to round to the nearest hundredth yet. I'm going to go maybe 4 decimal places. I don't want to do the whole thing that the calculator gives me because that's so much. But I get out of this, calculator gives me 1.2661. 1.2661. So I want to make sure that I have plenty of decimal places so that when I'm done with all the steps, I can round to the nearest hundredth and know that it's right. Now, where is cosine positive? Cosine is positive in quadrant 1 and quadrant 4. So you have this 1.2661 here. Quadrant 4, we need to do 2 pi minus 1.2661. And that will be, from our calculator, 2 pi minus 1.2661 5.0171 rounded. 5.0171. Okay. So we have x halves equals 1.2661 plus 2k pi, because we again are looking for all real solutions, so we're going to get this one by adding a full circle forevermore, and we're going to get this one by adding a first full circle forevermore. So we have the 1.2661 plus 2k pi, and also the 5.0171 plus 2k pi. There we go. So we have now expressed our solutions for x halves, all the solutions. Now to solve for x, we need to multiply by 2. So we're going to multiply everything by 2. And this will give us x equals. Now I'm going to go to the round of the nearest hundredth. So I have 1.2661 times 2. 2.5322. So now nearest hundredth, 2.53 plus. Here I get 2 times 2. That's just 4k pi. Now the 5.0171 times 2. 10.0342. So 10.03 rounded to the nearest hundredth. And again, plus 4k pi. This is the answer and the key. This is the final answer. The issue you will have if you round too early, had I rounded this to 2.67, then when I doubled it, I would have been off. These would not have been correct. So you want to only round the very last step. Now I did round a little bit early here, but I rounded with double the precision that I needed to, so that the mistakes would happen maybe this decimal place, maybe this decimal place, this mistake might happen, but not affecting my nearest hundredth. So if you need to go to the nearest hundredth, give yourself some extra decimal places, or don't round at all until you're very done, final answer, and then you can get your rounding much more precise. All right, that completes the review of Chapter 3 and Chapter 4. I hope it was helpful.